This video is about prime factorization and equivalent expressions. In the next section, we're going to talk about prime factorization, which means we just want to find the numbers that you can multiply to get to 848, and they have to be prime. So let's begin with looking at 848 and determining what kind of number it is. And you can see that 848 is an even number. So if it's an even number, it is divisible by 2. So 2 goes into 8 4 times, and then half of 4 is 2, and half of 8 is 4. And so there's our factor tree, and 2 is prime, so we're going to circle 2. Now we look at 424 and we ask, is it an even number? It is. It's an even number again. So again, we can break it down into 2 times, and half of 4 is 2, half of 2 is 1, half of 4 is 2. And 2 is a prime number, so we're going to circle that. We look at 212, and it's an even number again because there's a 2 in the ones place. It's an even number. So we can break that down into 2 times. Well, 212, I'm not really sure. So I'm going to look at 212 and look at 212 as 200 plus 12. I know that half of 200 is 100, and I know that half of 12 is 6. So half of 212 is 106. That makes it easier for me because 212 is such a big number. So this is 2 times 106. 2 is a prime number, and 106 is an even number. So one more time, we're going to look at, this is 106 is the same as 100 plus 6, and half of 100 is 50. Half of 6 is 3, so that is half of 106 is 53. And so 2 is a prime number. Now the question is 53 a prime number? Well, the only way I can figure that out is if I check my divisibility rule. So let's start with just writing 2, 3, 4, 5, 6, 7, 8, and 9. Since 53 is not an even number, I know it's not divisible by 2, 4, 6, or 8 because it is not even. And then I can look at 5 plus 3, and that equals 8, which is not a multiple of 3. Not a multiple of 3. So because if it's not a multiple of 3, then it's not divisible by 3, and it's not divisible by 6, and it's not going to be divisible by 9. And the last one we have to check is, well, not last, but we can look at 5. Well, 53 doesn't end in 5 or 0, so it's not divisible by 5. And then is 53 a multiple of 7? And I know that it is not. Therefore, 53 must be prime. So now I factored into its prime factorization, but I need to write it using exponents. So this would be exponential form. So I look at how many times 2 repeats, and it repeats 1, 2, 3, 4 times. So that would make it 2 to the 4th times 53. And that would be prime factorization of 848 in exponential form. So to solve a problem which asks you which pair of expressions are equivalent, they're asking you which of the two expressions are the same or have the same value. So as I look at the answer choices, I can see that A is a very long term. B has some long terms too. A looks like it's more complicated to solve, so I'm going to start with the shortest one. Let's try starting with D. And we can see that 3x minus x would be 2x. And then 5 minus 5 is 0. So 2x plus 0 is not the same as 2x plus 10. So I can eliminate that as one of my choices. Then I can look at answer choice C. C says 2x minus 5 minus 6. Is that the same as 2x minus 11? Well, if I look at negative 5 and negative 6, that means I have a negative 5 going to the left direction and a negative 6 going also the left direction. So I combine those and that becomes 2x minus 11. And that, so 2x minus 5 minus 6 is the same as 2x minus 11. So my answer choice would be C. And so let's just continue to check B just in case we had made a mistake. So answer choice B says x plus 5, that's x plus 5 minus 2 times 6. So don't forget to use PEMDAS order of operations. That's parentheses and exponents first. We don't have either one of those in our expression. So next step is to use multiplication or division, whichever comes first. And so we have a 2 times 6, which is 12. So now this expression is x plus 5 minus 12. And so 5 minus 12, 5 going to the right, 12 going to the left. That means I have a negative 7, x minus 7. And they're asking if that is equal to x plus 7, and that is not equal to x plus 7. So then we can look at the last one. So answer choice B is not a good answer, neither is D. Okay, let's look at answer choice A. Answer choice A starts with 3x, and that's 3x plus 5 plus 2 times the quantity 6 plus 3. So following PEMDAS, we look at parentheses first. 6 plus 3 is 9 times 2, that's plus 5 plus 3x. And so let's continue with multiplication and division. So here's 18, 3x plus 5 plus 18. And then we add, and that is 3x plus 23. And is 3x plus 23 equal to 3x plus 25? The answer is no, which proves that answer C is correct. If the way we solved it in the earlier part of the video was difficult for you, you can always substitute the variable with the number 2. So for instance, let's look at letter C again. And if it was 2x minus 5 minus 6, we would simply substitute the x with a 2. So that would be 2 times 2 minus 5 minus 6. And that would leave you with 4 minus 5 minus 6. And minus 5 minus 6 is negative 11. And 4 minus 11 would be negative 7. So let's check the other side. Is this equivalent to 2x minus 11? Again, we substitute the x with a 2. We multiply 2 times 2 minus 11. Now it would be 4 minus 11, and you can see that the value is the same. Negative 7 is equal to negative 7, and our answer is C. Now pause the video and evaluate each expression, A, B, and D, with the number 2, and check back with the video to see if your answer is correct. Okay, welcome back. I hope that you were able to solve or evaluate each of the expressions. As you can see, A turns out to be 83 on the one side and 31 on the other, so those are not equivalent. B was negative 5 and 9, and D was 4, and the other side was 14. So I hope you got plenty of practice from this, and review the video if you're confused about anything.